students. Today we are going to discuss on the topic of set. In this topic, we are going to discuss the basic concept of set, and we try to solve a problem related to the set also. Let's start with a definition of set. First, we have to define set. In mathematics, a set is a well-defined collection of objects. These objects can be numbers, symbols, elements, or any other entities. In mathematics, we can add different numbers, symbols, elements, or other any entities. Sets are typically denoted by curly brackets. In mathematics, we denote set by curly bracket, which is represented by this type of bracket, and their elements are listed within these braces separated by commas. In this set, the elements of the set are separated by commas inside these brackets. An empty set containing no elements is denoted as uh, curly bracket, empty curly bracket, or denoted as phi. Mm. Let's start some example to understand the definition of set from here. The set of natural numbers less than 5 can be denoted as 1, 2, 3, 4. Then the set of colors in a rainbow could be represented as red, orange, yellow, green, blue, indigo, and violet. Now we are moving to the topic of properties of the set, which follows a certain principles. Here are some principles we are going to discuss about them. First one is uniqueness. Each element in a set is a unique, meaning it doesn't contain duplicates, which means the element of set cannot be repeated in a single set. Next one is no specific order. The elements within a set are not arranged in any particular sequence. The elements inside a set do not have any particular sequence. Next one is well defined. The description or properties of a set should be clear. Now we are going to discuss about operations of set. Here we are going to discuss about 4 operations of set. First one is union, which is represented as capital U like structure, uh, which means common and remainder from both sets. It means if we list out the elements, common element from both sets, and then remaining element from the both sets. Next one is intersection. We write inverted U like structure for the representation of intersection, which means the common from both sets. We list out the common element from the both sets, which is called intersection. Next one is complement, which is represented as bar symbol here. Uh, it means not from a given set. We list out the other element which is not do not belongs to in a given set. Next one is difference, which is represented as minus symbol, uh, which means not in the first set but lies in the second set. Now we are going to discuss about Venn diagram, which is the most important topic for the set theory. Uh, First of all, begin with a definition of Venn diagram. The Venn diagram is the visual representation of the relationships between sets. Here, the in the picture, we have two sets here, A and B. The relationships between A and B are represented here in different ways, which we have discussed about previously on the topic of operations of set. Uses overlapping circles or other closed curves to denote sets and their intersection. Here the shaded portion here, green shaded portion are the relations between the function of set A and B. Areas where the circle overlap represent the element that belong to the both sets, while that the areas outside the circle represent elements that belong to neither set. Here, the area where you can see in the first picture here, the shaded portion is the overlapped portion of the for the set A and B. So it represents the relation between A intersection B. Then when shaded portion is large in the second case, here it represented of the relations of uh, A union B. And other, for other relation you can see other Venn diagram here. Mm, let's see some symbols of the set theory. Uh, in the first, we have curly braces here. The symbol curly braces represent the set here. Uh, you can see example here, and explanation of the symbol. This symbol is written here. A collection of objects. Then second one is intersection, which belongs to both set A and B. Here we can find out this relation. Next one is union, which means belong to set A or set B. Then next relation is about proper subset, which means the that is contained in the another set. Here is the symbol for proper subset. And next one is subset, which is means a set that is contained in or equal to another set is called subset. Next one is not a proper subset. We can represent this as a cross symbol of proper subset here. A set that is not contained in and the set is represented as this symbol. Next one is superset. Uh, when set B includes set C, it will be called as superset, which is represented as like this symbol. Next one is a member, which also represent as belongs to. For example, 3 belongs to A. From set A, we can see 3 belongs to set A. Next one is not a member, which also represent as does not belongs to. For example, 4 is does not belongs to A. In this set A, 4 does not belongs to set A, so we can represent this as 4 does not belongs to A. Uh, Next one is operations of set. We have discussed earlier about the operations of set. For example, A intersection B is represented as this symbol. Next, the shaded portion is the relation operation of set between A and B. Next one is A union B. The shaded green portion represents A union B. Then next, the shaded portion represents A complement. Next, shaded portion represent A intersection B complement, or which can be represented as only A. In this Venn diagram, this green shaded portion represent only B or A A complement union B. Next, represent A union B complement. The shaded portion represent A union B complement. In this diagram, this diagram represent A complement union B. Next one, this Venn diagram represent A intersection A complement union B complement, or A intersection B whole complement, which is also known as the De Morgan's law of set. Next one is A complement intersection B complement, which also belongs to A union B whole complement. These last two Venn diagram represents the uh, very important law of set, which is also known as De Morgan's theorem. Next, we are going to discuss about cardinality of set. The total number of element present in a set is called cardinality of set. For example, let's take a set A, which represents the elements A, B, C, and D. Then its cardinality is denoted by, let's count the element here, 1, 2, 3, 4. Uh, so the cardinality of set Na will be equals to. Now let's discuss about types of set. Here we are going to discuss about different types of set on the basis of their characteristics, properties, or elements they contain. Some of the common types of set includes, here we are going to discuss some of the types of set here. First one is, we are going to discuss about finite set. A set that contain a specific number of elements is called finite set. For example, a set 1, 2, 3 is a finite set since it has a countable number of sets. For a set to be finite set, it must contain the countable number of elements. Next one is infinite set. uh, just reverse from the finite set. A set that contains an unlimited or an endless number of elements are called infinite set. For instance, the set of all natural numbers 1, 2, 3 dot 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 dot, dot is an infinite set. In the infinite set, the number of element may be unlimited or endless. Next one is empty set or null set. From the definition, we can also conclude that it is the set which contains no element, which is denoted by phi or empty curly braces. It is unique and serve as the basis for the set theory. For any set, the empty set or null set might be only one, which do not contains any elements here. Next one is the singleton set. A set that contain only one element is called singleton set. For example, 5 is a singleton set. Next one is equal set. Uh, Two sets are considered equal if they have precisely the same elements. For instance, set A, B, C and C, B, A are equal sets because they contain the same elements even if the order differs. Here, order is not considered here, so we just look at the element of the both sets. Here, both sets contains A, B and C as the elements, so these two sets are called as equal set. Next one is subset. A set A is a subset of another set B if all elements of set A are also element of the set B. If every element of set A is in set A, B, but set A is not equal to set B, but then A is a proper subset of B. For instance, 1, 2 is the subset of 1, 2, 3, denoted as 1, 2 is the subset of 1, 2, 3, and it is also a proper subset because 1, 2 is the subset of 1, 2, 3. Here subset is the uh, group of elements, less number of elements which belongs to, which is derived from the larger group than the given set. Next one is universal set, which refers to the set that encompasses all elements under consideration in a particular context. It is often represented by the symbol U. Universal set is the largest set possible uh, uh, in the uh, certain consideration or of particular context. Now, moving forward from the types of set, uh, next types of set is disjoint sets. Sets that do not have any common elements are called disjoint set. For a set for two sets to be disjoint, the two sets should not have to share any elements. For example, we can see in the screen here, we have two sets here, 1 2 3 and 4 5 6. These two sets are known as disjoint sets because they share no elements. Next one is power set. The power set of a set is the set of all its subset. For example, if A equals to 1 2, then the power set of A denoted as PA would be uh, phi, or empty subset uh, 1 2 1 2. These are the power set for the set A. Complement. Next we have the type of set is complement. Given a universal set U and subset A, the complement of A denoted as A bar consists of all elements in U that are not in A. Here the symbol A bar represents the elements which are not in A. Uh, Here you can see in the screen that the some of the related formula which is related to the set theory, and you can see the visual representation of the operations of set here also. Next we are going to discuss about some real life application of sets. I have summarized this in a sentence here. Sets are foundational in various branches of mathematics and have applications in computer science, logic, and many other fields. The properties of set or set theory is foundational thing for the different field like mathematics and computer science, logic, and many other fields. Let's solve a problem related to set theory here. Here is a question in the screen. I think you can solve by yourself here. Now we are going to solve in the screen here. First, let me assume something here. Let M be the set of students is studying mathematics, and P be the set of students studying physics. We have two sets here. NM represent the number of elements in the set M, which is also known as the cardinality of set M. Next one is NP represent the number of elements in set P, and number of M intersection P represent the number of elements in the intersection of sets M and P. Now moving forward, we are going to write the value of total number of students, which is represented as NU, which is given as 500 in the question. Next, number of students studying mathematics is given as 300 here, which I have represented as NM here. And then next, number of students physics, which is represented as NP, which is given as 200 in the question. Next, in the question, it has given that number of M intersection P equals to 150. Now move to the question here. To find the number of students studying mathematics only, we can represent this the number of students studying mathematics only as n not m, which is equals to nm minus nm intersection p, which putting the value of these variables here, 300 minus 150, which belongs to 150. This value 150 is the number of students studying mathematics only. Next, move to the another question here. We have to find the number of students studying physics only. We can use the same formula as the question number A here, but we replace the number of students studying mathematics with a number of students studying physics only. From this, we can find the number of students studying physics only is the 50. Next question. Next question, we have to find the number of studying students not studying either subject. The students which who do not study neither mathematics nor physics is we have to find out the number of students not studying both subject. which is represented as n m union p whole complement. We have the formula to calculate the number of m union p complement, which is nu minus nm plus np minus nm intersection p. Here we have put the value of the uh, uh, given sets here. Then we can find the number of students not studying either subject will be equals to 150 here. Next, in question number D, we have to find the total number of students studying at least one of the subjects here. We can consider the both subjects here also. Uh, the formula to calculate the students studying at least one subject will be nm plus np minus nm intersection p. Here we have put the value of the given sets here. We can find the answer is 350. Thank you for listening me for this time, and I like to request you to subscribe my channel also, and share this video with your friends. Thank you so much.